know, I am a famous architect. And being an architect, I need to understand not only area, but also perimeter. So in today's lesson, we're going to go over both area and perimeter and what they mean, and we're going to go over some questions and answer them. Let's get started. Okay, guys, before we begin our lesson, let's get some background information. You might be asking yourself, what is area? Area is the amount of space inside a closed two-dimensional figure. So whenever we're looking at a shape and you're trying to find out the area, there are two different ways that you can determine what the area of the shape is. Let's look at option 1 first. The first option is by using unit squares. Remember, unit squares are all the same size and they equal 1 of a particular unit. So whenever you put all of your squares inside of your shape, you just count them up to determine the area. So in this shape, we have 6 squares, so the area of this shape is 6 units. Let me write that in my blank. Area equals 6 units. Awesome work. Let's look at the second option that you can use in order to determine the area of a shape. The second way that you can determine the area of a shape is you can look at the numbers on the outside of the shape. So the length of the bottom of this rectangle is 3 units, so you get that 3. And the side of this rectangle is 2 units. You get that 2, and you multiply them together. 3 times 2 equals, you're right, it equals 6. So the area of this rectangle is 6 units. Now that we've cleared up what area is, let's move on to perimeter. You might be asking yourself, what is perimeter? Perimeter is the distance around a two-dimensional shape found by adding the lengths of the sides. So in area, we're multiplying 2 sides together, and in perimeter, we're adding all of the sides of the shape. Now, just like area, there's 2 options that we can use in order to find a shape's perimeter. Let's check out option number 1. For our first option, you can also use unit squares to find the perimeter of an object. So, there's 6 squares inside of this box, but that's not what I need to understand to do my perimeter. How many squares are on the left side? 1, 2. So this side has a length of 2 units. How many squares are on this side of the shape? 1, 2, 3. So this has 3 units of length. Same thing for this side. How many squares do we see? 1, 2. So I'm going to put a 2 there. In the bottom, 1, 2, 3. Now that I've found these lengths, I'm going to add all of these numbers together. So 3 plus 2 plus 3 plus 2. 3 plus 2 is 5. 3 plus 2 is 5. And then 5 plus 5 equals 10. So the perimeter of this shape has 10 units. Let's check out the second option that we can do whenever we are finding the perimeter of a shape. Now, some shapes might give you the units already on the side instead of the unit squares. So in this picture, it shows us that we have 3, 2, 3, and 2. So you just do the same thing. You would add up all of the sides. So 3 plus 2 plus 3 plus 2. Okay? So because I did my math over here, I already know that this perimeter equals 10 units. Now that we've cleared up what area is as well as what perimeter is, let's get started on some questions. Alright guys, let's get started on this first question. The question reads, Miss Lovell is trying to build a house on this plot of land. She needs to figure out the perimeter of the land in order to start building. What is the perimeter? Okay, so one thing that I really want to point out in the word problem is that I'm looking for perimeter. Whenever we're finding perimeter, remember we're adding all of the sides together. So, with that being said, I'm going to look at the sides of the plot of land. So, I have 40 yards, 15 yards, 40 yards, and 15 yards. So, I need to add all of these numbers together. So, I'm going to be adding 40 plus 15 plus 40 plus 15. Whenever I'm adding multiple numbers, I like to get two at a time and add them together. So I'm going to go ahead and I'm going to take out the 40 and the 40 and I'm going to add those together now. So 40 plus 40 equals 80. Okay, now I'm going to add 15 and 15 together. 15 plus 15 is 30 because the 5s make a 10. You carry it over. 1 plus 1 plus 1 is 3. So now that I have 80 and 30 left, I'm just going to add those together. 80 plus 30 equals 0 plus 0 is 0. 8 plus 3 is 11. So the perimeter of the plot of land is 110 yards. Fantastic work, guys. Let's move on to our second problem. All right, guys, problem number 2. Let's get started. Miss Lovell designed an L-shaped swimming pool. The perimeter of the pool is 22 meters. She labeled 5 lengths of the pool. What is the length of the 6th side? Okay, so there's lots of important information I want to highlight in this problem. First off, we're not looking for the perimeter. They gave us the perimeter already. It said that the pool has a perimeter of 22 meters. The problem that we have to figure out is what is the length of the 6th side. So there's 2 different ways that we can solve this problem. The first way I'm going to solve this problem is by adding all of the numbers up and subtracting it from 22. So let's do that now. 2 plus 6 is 8. I'm going to bring that 8 down. 8 plus 5 is 13. Let me write that down as well. Going to bring that 13 down. 13 plus 2 equals 15. Now we have to add one more thing to 15. 15 plus 3 equals 18. Okay, so I just added all of the numbers of the lengths of 5 sides of the swimming pool. I have to find this length though right here. So I'm going to get the perimeter, which is 22 of the pool, and I'm going to subtract that by 18. Let's do that over here. 22 minus 18 equals, I'm going to have to borrow. This becomes a 1. The 2 becomes a 12. 12 minus 8 equals 4. And 1 minus 1 equals 0. By doing it this way, I have determined that the length of the 6th side of the pool is 4 meters. Now that we've solved it this way, I'm going to show you one more way to solve this problem. Let's do that now. Okay, the second way that you can solve this problem is just by imagining that this L shape is actually a rectangle. So what would the rectangle look like? I like to do dotted lines to show what the rectangle would look like. So that's my imaginary rectangle. Now, like you already know, a rectangle has opposite sides of equal length. So what this means is that the top and the bottom are the same length. So the bottom of this pool is 5 meters. So the length of this side and this side have to also equal 5. Whenever you add 2 plus 3, what do you get? You're right, you get the answer of 5. So, because that's true about the top and the bottom, that's also true about both sides. So, the left side of my L-shaped pool equals 6 meters. In order for this to be a rectangle, this entire side would also have to equal 6 meters. This section of the pool has a length of 2 meters. So what can I add to 2 to get to 6? You're right. 2 plus 4 equals 6. So if this length is 2, it must mean that our unknown length is 4 meters. So after working this problem out 2 different ways, I realized that the length of the unknown side is 4 meters. Fantastic work, guys. Let's move on to our next problem. All right, guys, this third problem looks a little bit different. It reads, Miss Lovell drew this rectangle. It has an area of 20 units and a perimeter of 18 units. Which rectangle has the same area but a different perimeter? Ooh, okay. So in this problem, we're trying to find the shape that has the same area. So the area of Miss Lovell's rectangle is 20 units. So whenever we're looking at option 1 and option 2, we have to make sure that this shape has an area of 20. In addition to this, we have to make sure that the perimeter is different from Miss Lovell's rectangle. The perimeter in Miss Lovell's rectangle is 18 units. So if it's a number that's different than 18, we're good. Let's get started with option number 1. For this one, I'm going to just go ahead and count the unit squares to find the area for option number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So our first answer choice has an area of 16 units. Let's see if we can find the perimeter. Let's count the sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Now all I need to do is add these numbers up. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. So the perimeter of option number 1 is 16 units. So it does have a different perimeter, but it had to have the same area. So option 1 is not correct. Let's move on to option 2 and see if that one meets the requirements. First, I'm going to count the unit squares in order to find the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the area of option 2 is 20 units. So far, this has the same area as Miss Leffel's rectangle. Now I have to see if it's going to have a different perimeter. Let's count the sides of our shape. 1, 2. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 10 is 20. 20 plus 2 is 22. 22 plus 2 is 24. So the perimeter of this shape has 24 units. Because the perimeter is different and the area is the same, option 2 is my answer. Great work, guys. Let's move on to our last question for the lesson. Our last question is very similar to the one we just did. Let's read what it says. Miss Lovell drew this rectangle. It has an area of 24 units and a perimeter of 20 units. Which rectangle has the same perimeter but a different area? So this question is very similar to the one we just did, but instead of finding the same area, we're going to be trying to find the same perimeter. It already told us that Miss Lovell's rectangle has a perimeter of 20 units and it has an area of 24 units. So we need to find the same perimeter in a different area. For these two options, I'm going to multiply and add rather than count the unit squares. Let's get started on option 1. So I'm going to work on area first. So I need to find the length and the width of the shape. 1, 2, 3. So 3 on that side. 1, 2, 3, 4, 5, 6, 7 on this side. 7 times 3 equals, you're right, it equals 21. So the area of option 1 has 21 units. Let's find the perimeter of this shape. Because the top has 3 units, it must mean that the bottom also has 3 units. And because the side has 7 units,
this side also has to have 7 units. Let's add all of these numbers together now. 7 plus 3 is 10. 10 plus 3 is 13. And 13 plus 7 equals 20. So, option 1, the perimeter is 20 units, which matches Miss Lovell's rectangle. The area is 21, which does not match Miss Lovell's rectangle. So, option 1 might be my answer. Before I choose it, though, I want to see if option 2 is potentially correct as well. On option 2, I'm going to do the same strategy I used for option 1. So let's first find the area by multiplying the sides. 1, 2, 3. This side has a length of 3 units, and the top has a length of 1, 2, 3, 4, 5, 6, 7, 8. Now that I have both of these sides, I can multiply 8 times 3 to find the area. 8 times 3 equals, you're right, it equals 24. So the area of option 2 is 24 units. Now let's work on perimeter. Because 8 is the length on the top, I know it must be the length on the bottom. Same thing for the number 3. Let's go ahead and add these 4 numbers together. 3 plus 8 is 11. 11 plus 3 is 14. And 14 plus 8 equals 22. With that being said, the perimeter of this shape has 22 units. Because the perimeter is 22 and not 20, option 2 cannot be my answer, which means option 1 is the correct answer. Y'all did a fantastic job with these problems. I hope this helped you better understand the connection between area and perimeter.
Thank you for all of your help today. I've had so much fun learning with you. I'll see you next time.